Hello guys, in this short video I'm going to explain the technical details about this lab setup because I'm going to use this lab in my future videos. Well, let's start. Uh, um, a couple of weeks ago I had a call from one of European training centers and the manager asked me to prepare a short video to assess my abilities to deliver, to explain some network-related technologies to a wide audience. So, out of curiosity, I have assembled this lab scheme, which uses mostly Cisco iOS devices currently. But I'm not going to limit myself and in any sense to stop at this stage, at this step. I'm going to develop this laboratory scheme further as far as the hardware resources will allow me, because I have quite limited resources. So, what is this scheme about? Well, this is the network scheme or network of a virtual enterprise that has three offices. One of them is headquarters office, and the other two are just branch offices. One of them is middle-sized branch office, and the other one is very small. Also, I have a backbone internet here. Let me move this oval off the place. As you can see, there are also only two routers. These are also Cisco routers that constitute an internet backbone, so to say. Nonetheless, they run BGP, internal BGP between them. They advertise prefixes of customer connections. They use OSPF routing protocol inside this autonomous system. And as I said, I will develop this network scheme also in part of internet backbone, laboratory internet backbone. So basically the design of each of the offices of this virtual company follows best practices. I have a core, network core. I would say I use collapsed core here without setting apart some special high-speed devices or high-speed images. Just the switching block for internet access, switch block for user access. This is in headquarters office, and collapsed distribution and core in remote branch with redundancy, and without redundancy in the other small office of the company. Also, I have connected this Linux box here. I connected it to the external network so that I was able to connect to the devices right from my laptop, from my home, or from my place where I have access to the laptop or a PC. So basically, this Linux box, it is a Ubuntu 18.04 server. I configured it as SSH proxy jump. So I'm connecting to this external interface, but due to proxy jump feature of OpenSSH, I get immediate access to any of the devices inside the scheme, provided that they have routes, that the scheme has all the routes to all the devices, to all the prefixes, except maybe for user-defined VLANs, which are addressed from 10.0.0.0/8 block. I'm using just 3 blocks of the 10th subnet. It is these are 10.0.0/16 for headquarters office, 10.1.0.0/20 for middle-sized branch office, and 10.1.16/20 for small office. Okay, so first let me show configs of some of the devices on this scheme. For this reason, I'm going to use my SSH JumpHost from the very beginning of this video. So I'm going to use my terminal, and I'm going to connect to any of the device of this network scheme setup. So SSH, say let's connect to switch 13. Okay, 13 and lab int. As you can see, I automatically connect to intermediate proxy JumpHost, and then my SSH session is relayed to the target device. A bit later in this video, I will show you the configuration of SSH on my local PC, on my local laptop. So basically, that's it. I'm in the switch 13. As you can see, all the configurations are in place. Every office has routes to every of the other offices. Internet backbone is working also okay. So IP addressing is in place. Also, I have distributed in advance the SSH keys, my SSH key, my public key, to all the devices to be able to use this node as a SSH proxy JumpHost or Bastion host, if you wish. Okay, so basically we can check VLANs, show VLAN brief, which VLANs are configured here. Well, this is the L3 switch, almost purely L3 switch. As you can see, I'm using iOS on Linux, Linux L2 Advanced Enterprise K9, version 15.2. So it is very feature-rich image, but only for lab environment. Let's connect to some front-end routers of the company. For example, to R1. Okay, this is the R1. Again, show run. What we do have here. So usernames, a couple of locally defined users. I'm still not using the external authentication methods like Radius or TechX+. I'm going to add them in the future, of course. So this is just an initial setup. Also, I have configured IP security here. I'm using pre-share authentication as an Internet Security Association and Key Management Protocol policy. This is the password for VPN tunnels. I'm using DEM VPN phase 3 in my lab setup. And I'm using this transform set for IP security phase 2 VPN sessions. Okay. This is the transform set, and this is the VPN profile in which I use this transform set. Okay, I also have a configuration of tunnel interface. As you can see, this is the generic routing encapsulation multi-point tunnel interface, which is a requirement for DEM VPN technology. And also a few commands that actually constitute the DEM VPN configuration on the next hop server, because router R1 as well as router R2 are two next hop routers, next hop servers that hold mapping between external interfaces of branch offices and tunnel IP addresses of their tunnel interfaces. This is the setup for DEM VPN cloud over the public internet. Okay, there are some physical interfaces configured. The other are shut down. And as you can see here, I'm using EIGRP in the so-called named configuration mode to be able to add the configuration for IPv6 network stack in some future. Okay, let's also check some remote office maybe. I'm sorry, I forgot to use my terminal. This is the R5, so I can just edit this line. As you can see, the lab scheme has complete routing information, and I can get right from my own laptop into any of the devices inside this lab. So, show CDP neighbors, for example. I can see here R7, only R7. Not only R7, but switch SW as well, because those are the only two neighboring physically adjacent devices to R5. Okay. So, well, actually, this is a configuration flaw about router R7, because, you know, this router, as it turns out, it advertises CDP information about itself to the external device, which does not belong to the local autonomous system of this provider. But actually, I have had a real-life example of this flaw, of this mistake. When I used one of providers back in my home city, once I connected my virtual router to the physical interface of my computer and just fired up my device and thought, what if I check for CDP neighbors? And indeed, I knew instantly a lot of information about the network device to which my home was connected. So, guys, if you are from an internet service provider or just any enterprise, don't forget to turn off or disable CDP protocol on external interfaces of your network devices. Okay. So what else can we check? Show IP interface brief command. This is the command to check locally configured IP addresses on local interfaces. As you can see, there are two tunnel interfaces, and these are 5. And it uses just serial connection. The serial interfaces and serial connections are not so widely used nowadays, at least in Russia. I know that in some maybe other countries it is not so, and serial connections would be used quite extensively. But I'm judging on abilities and different options that have citizens in most cities. Regarding rural places, of course, it is not so. And sometimes you have to use serial interfaces. I know that, for example, in Europe, still DOCSIS standard is used to transfer internet traffic over the cable TV facilities. And even ADSL is still used somewhere. Okay, so what else? So basically, I'm not going to show you the configuration of every device. That is not maybe interesting for you. But the last device I'm going to show you the configuration of is, well, let it be R7. Okay, for R6 and R7, I do not have SSH jump config because actually this stems out of the approach to this laboratory setup. You know, this is the separate network, separate autonomous system by definition. This is the internet service provider, independent administration. Okay, so I did not configure, for that reason, these two devices to be accessible through this JumpHost. Maybe I will fire up another JumpHost just out of curiosity and to be as close to the real life as possible in my test setup. But currently I can't connect directly to these routers. So let me just connect to their virtual physical consoles, so to say. So basically, as I said, they run BGP, show IP, BGP summary, BGP summary. As you can see, there are only two routers that run BGP. I'm going to expand this network in the future to the extent that is allowed by the resources that are set aside for this virtual environment. Okay, show IP BGP route, for example. Route ambiguous command, show IP BGP, not route but router. So let's check first routing table. For this reason, we have show IP BGP command without any further options. As you can see, all the prefixes that R7 knows are either locally generated in BGP process or received as one of the two alternative. No, not alternative. Either locally generated or received, prefixes received from the internal BGP peer. This small letter I stands for internal BGP peer routing information. And you can see here the next hop. This next hop is actually the IP address of neighboring router, R6 in this case. So let me check. So CDP entry R6 2.6 and 1.6, and here we have 3.1 here. So yeah, basically this is the addresses of interfaces on the neighboring device on R6. And it would be better if I connect directly to R6 to check this, specifically on R6. So this is the interface Ethernet 0/2. Also for as an IGP solution, internal gateway protocol, I'm running here OSPF, so show OSPF neighbor. Show IP OSPF neighbor will show me information about routing adjacencies for the OSPF protocol. And as you can see, there are two routing adjacencies, both of them with the same neighboring device, as you can see here. We can also check show IP OSPF database. Not so much here, not many link state advertisements are here, just type 1 router link states and type 2 network link states. There are no any other link states here, types of link states here, because I run only area backbone, area 0 here. You can conclude this from the show IP protocols output. As you can see, only area 0 is configured on both the routers. Area backbone, area 0. Okay, so this is the very basic setup for the internet backbone. Now, to the point of SSH jump, right? I promised you to explain the configuration of this SSH jump host. Let us change to .ssh directory in my home directory, and let me use less. Okay, this is the lab config file that is inherited in the configuration file for main configuration file that is present in my home directory in .ssh subdirectory. Here you can see the definition of all the enterprise network devices here in this file, including this jump host, which is named which has host name cfg01 and domain ent.lab.int, enterprise.laboratory.internal. So this is the IP address of this jump host, and these are definitions of all the enterprise network gear or network devices that you can see here in the network diagram. Okay, so here we have a host directive which defines the host name. You connect from your command line interface from your laptop by this name. Here the host name field stores the IP address. I think FQDN also would do here, provided that you configured DNS for your environment. But since I'm using my own DNS, I don't want to interfere with laboratory DNS. And this proxy jump directive is a very good and very useful directive in configuration of SSH client, which tells that in order to reach this host, I need first to jump to this one, to intermediate jump host. And my SSH client will automatically resolve this name to this IP address without any DNS queries, because I'm using IP address as a host name here. And then my SSH client will use this JumpHost as an intermediate host to get to the target device. Okay, and this file is inherited in my main config file. Let me just filter the information in my config file. Config grep and lab int dash a and say let it be 20 lines below this line. Okay, here is the excerpt from my SSH config file. So as you can see here, I'm including this lab config into my main SSH config, and I'm setting a few options here to be able to contact my JumpHost as well as my Cisco gear. So first, I'm pointing my SSH client to my identity file. This is the private SSH key that I have generated beforehand. This is my username that I'm going to use while connecting to the devices in laboratory scheme. Forward agent means that you or your JumpHost must pass your identity on to the devices inside your laboratory scheme or to the target devices that you are connecting to. I'm suppressing some unnecessary output to the dev null. Also, I am using specified key exchange algorithms. This is the first phase of establishing secured communication through the public networks. KEX algorithms use some mathematical features that make almost practically impossible to calculate the initial parts of the final key with which you secure or encrypt your phase 1 session. Okay, so if you are interested in this, you may Google about Diffie-Hellman algorithm or elliptic curve algorithm, or I can prepare a video, but I don't promise that this video will come out soon. So, and some other not important options. So that is the setup of JumpHost. Now, I would like to share you some of my achievements in regards to network automation. So let me connect to configuration 01 node. On which I have configured as Saltmaster. What is Saltstack? Saltstack is a configuration management system. It allows you to configure and manage the configuration and troubleshoot a very large infrastructure of totally different devices. Ubuntu servers, CentOS or Red Hat servers, different network gear. It uses the system of pillars and Saltstack formulas. Saltstack formulas can be downloaded from the public repositories that you can find on the github.com site. Okay, so let me just show you a few tricks with when using Saltstack. For example, I can address all the devices all my configured network devices. So just to show you that it works, I'm going to use the test.ping function of test module of Saltstack. Asterisk means globing. This is a meta character that is substituted for everything, for every device. As you can see, some devices return true value. Okay, so basically these are devices that you can see in this laboratory diagram, except routers R6 and R7. But as I have explained just a couple of minutes ago, these belong to independent autonomous system, and I thought that it would be good to mess up these devices with the other devices in this scheme. I'm going to make this laboratory setup be as much close to the real-life scenarios as possible, because otherwise I'm not interested, and I feel like it is not quite interesting, right? You are facing each every day with real-life scenarios, not just laboratory setup. So I'm just striving to bring my laboratory setup as close to the real-life scenarios as possible. So let me show you the Saltstack in action. Actually, this is not just Saltstack, because as far as the network device is concerned, also Napalm is used here. Salt plus Napalm. So, for example, router 1. Let me ask for its ARP cache. Since this is the virtual lab setup, we experience, as you can see, I experienced the delays here. But in real life, these delays are not that big, that large, or that long. So, as you can see, this is the output of Salt router 1 net.arp command. I can return the output in JSON format. And let's compare these two outputs. They are about the same ARP cache of the same device with what we actually do see in the ARP cache of this device. So let me connect by means of SSH to R1. Okay, here I have to use I have to specify my user, because I didn't configure SSH config on this node, just on my laptop. Show IP ARP, and let me go out of this device and repeat this command. Let me just compare the outputs. You will see that the information that is output by this command is the same as we can see here. For example, let's take this this section. MAC address AABBCC006000. It's here, and age is exactly 119, as it is here. And this is the interface Ethernet 00, as you can see here. And the address 172.16.1.1, it is here. And this holds true for any other section of this output. So basically, centralized configuration management allows you to, or opens large opportunities very wide opportunities, better to say, in configuring your scaled environment. Okay, but I will devote a separate video to this topic, the topic of network automation in general, and Saltstack and Napalm in particular. So basically, that's it. I feel like the video is going to be not quite short, so I must stop at this point. If you liked this video, just leave your comments, like, subscribe if you are interested in this my channel. And thank you for watching. Have a nice day, guys. Bye.